In this video, we're going to do examples 4 and 5 from the mole lesson. So let's take a look at number 4. Find the number of molecules in 2.5 moles of NH3. Let's use our guess method. So guess, what are we given? Well, in this question, we're given the number of moles is 2.5 moles. And we're given the Avogadro's number is Na is equal to 6.02 times 10 to the power of 23 NH3 molecules, that's our conversion factor, in other words, for 1 mole per mole. And you don't really need to put the 1 there. You would if it was a conversion factor, but here we're just putting per mole, but it still works. And so what are we looking for? We're looking for the number of molecules. So we're looking for big N. We don't know what that is, so it's number of NH3 molecules, because that's our particle. And so we're going to write out our equation. Our equation, we know that big N is equal to little n times Na. And we can then substitute and solve. So we have that big N is equal to the number of moles, which is 2.5 moles, times Na, which is 6.02, times 10 to the power of 23 NH3 molecules per that mole there. We can cross mole out, and we get 6.02 times 10 to the power of 23 times 2.5. And so in our solving part, we get that N is equal to 1.505 times 10 to the power of 24 NH3 molecules. But as you know, we have to have a therefore statement as our final S there. And it also needs to be at the proper number of sig figs, which is 2. So this looks like 2 here. So I look next door and it stays at 1.5. So therefore, the number of particles is 1.5 times 10 to the power of 24 NH3 molecules. So this 1.5 times 10 to the power of 24 NH3 molecules in 1.25 moles. Now let's try this question here. How many atoms of chlorine are in 3.45 times 10 to the power of 23 molecules of AlCl3? So we kind of did some of the work for you here. We gave you the number of molecules for AlCl3. Now let's put a conversion factor. Let's do that. Let's write that. We know that in 1 AlCl3 molecule, there are 4 atoms, right? But we're not looking at all the atoms total. We're looking at specifically the chlorine atoms. So in 1 AlCl3 molecules, there are 3 chlorine. So in 1 AlCl3, there are 3 chlorine. You could also write the conversion factor the other way around, but let's see which one we're going to use. Let's actually write it just for the sake of it. So, or you could write 3Cl for every 1 AlCl3 molecule. Okay. So what are we given? We are given the number of particles, 3.45 times 10 to the power of 23 AlCl3 molecules. And so what we're going to do is we're going to use our conversion factor method, because there's no real formula for this. It's just about using conversion factors. So really, I want to go from number of molecules to amount of Cl. I want to go from molecules to Cl. So what I'm going to do here, I'm going to show my work, is I'm going to write 3.45 times 10 to the power of 23 molecules. And I'm going to multiply that by one of the conversion factors there, the one that's going to get rid of, well, molecules for me. And I should actually write, let's do this to make this nice and neat here. AlCl3 molecules. Multiply it by the conversion factor that lets me get rid of molecules, which looks like it's, if we had to choose between A and B, think in your head, B, good. So times 3Cl for every 1 AlCl3 molecules. And so we can cross molecules out, and we put that in our calculator, 3.45 times 10 to the power of 23 times 3. And we get that that's equal to 1.035 times 10 to the power of 24 Cl atoms. But let's have our therefore statement, because this has to be the proper number of sig figs. We have 3 sig figs given to us. Don't count the number 3 here because that's an exact number. It's not really given to us in the question, but we have 3 sig figs given to us. So our therefore statement is therefore there are approximately 1.04, because we're rounding up since we want to make it an even number, 4 times 10 to the power of 24 Cl atoms. And that is our rounded answer to the correct number of sig figs. So we have 3 significant figures there. And so there we used our conversion factor to determine this. If I didn't give you the number of molecules and I said how many atoms of chlorine are there in, let's say, 5 moles of this, you would have had to convert to number of molecules first and then multiply by 3 atoms of chlorine. If I asked you for the total number of atoms, what would you have multiplied molecules by? If you're saying 4, that's right, because you have 4 atoms total. If I said aluminum atoms, what would you have multiplied it by? If you're saying 1, you're right, because that's just 1. There's only one aluminum in AlCl3. Think about it this way. I'm just going to do a quick little simplification here. Here's 1 AlCl3. In 1 AlCl3, you have 1 Al. But in 2, you have 2 Als. So you multiply what you have in 1 by how many you have, right? In 1 AlCl3, I have 3 chlorines. But in 2, I have 6. I just do 2 times 3. So basically, I'm just doing the number of molecules that I have times, well, the number I have in 1. And that's the general idea behind what we did here, just with bigger numbers that look scarier. But in reality, it's the same thing as that you would normally do with something a bit simpler.